Greetings and welcome. My name is Brian Waddy. We're continuing our look at combinatorics and probability, and we were specifically looking at our last video at combinations, which is calculating the number of arrangements where order is not significant. And we're going to look at just a particular problem where we'll have to consider whether or not it's a combination or permutation and consider three separate cases for the same situation. So suppose out of 15 students, let's say 5 are chosen as class officers. Okay? And let's consider this first case, where I just want to find out how many different groups of 5 could be formed. So regardless of who got what position, alright, so the order would not matter for this case, so this would be a combination. So this would be a combo. Out of 15, we're choosing 5. So according to our formula, that would be 15 factorial over 15 minus 5 factorial times 5 factorial. And I always forget to make my vinculum long enough there. And so let's simplify this. We've got 15 times 14 times 13 times 12 times 11 times 10 factorial, and I'm intentionally writing that as 10 factorial because I anticipate, let's see, I'm going to scroll over just to make sure you guys can see that. I anticipate that 15 minus 5 down here is going to be 10 factorial, which I'll be able to cancel out there in just a moment. So, and then 5 factorial is 5 times 4 times 3 times 2 times 1, but technically we never have to bother about the 1 since multiplying by 1 is not going to change it. So let's cancel out what we can, so that 10 factorials cancel. 5 and 3 is the same as 15. 4 and 2, let's see, what could I do with those? Well, 4 goes into 12 3 times, and 2 goes into 14 7 times. So my simplified version of this is looks like 7 times 13 times 3 times 11, and if I pull out my calculator here, I've got 7 times 13 times 3 times 11 is 3,003 possibilities. Right, so that's a case where order did not matter. Now let's consider the same example, except what if while we're selecting these groups, we are choosing their position as class officers. So let's say there's each has a different responsibility. So I'm still choosing 5 students, but now this time the order does matter. The first student chosen will say be president, then the second be vice president, etc. So that would be represented by a permutation of 15 choose 5. And because order matters, I'm expecting a number greater than the 3,003 from the previous example, because the arrangements are going to result in different possible outcomes. So this formula would be 15 factorial over 15 minus 5 factorial. Oh, with parentheses there. Actually, let me get rid of that. So this one's actually, I might even be able to use some of the work I did from the previous problem, but this one's easy enough. And all over, let's have, and that's just 10 factorial in the bottom. So what cancels out is those, and I think we can already see that 15 times 14 times 13 times 12 times 11 is going to be much bigger than our last answer. So let me Type this into my calculator. 13 times 12 times 11, and I get a much larger number of 36,300, or 360,360. There's a little eyeball there for you. So we do see that we have way more possible outcomes in this permutation of the same number of students, but because the order can be arranged in all sorts of different outcomes, we have a far more significant number of possibilities. And now let's consider a more difficult problem. What if we're still choosing, this time we're choosing 5 students, but out of the 15 we found out that 8 were girls and 7 were boys. Alright, so we still have a total of 15 students. And let's say how many groups of, let's say, 2 girls and 3 boys can be formed. So if I want to find out the number of ways that could occur, I have 2 combination events occurring here. So one is regarding choosing 2 of the girls, and the other is regarding choosing 3 of the boys. Right? So let's write this as 2 separate problems, and the number of ways this can occur is independent of the number of ways the boys can be chosen, so I could just multiply those 2 separate combinations in the end. So let's consider just the girls. So that's going to be a combination, since I'm just choosing groups, not divvying up responsibilities. And of 8, I'm choosing 2, and that will represent the number of ways I can choose 2 out of 8 girls. And I'm going to multiply by the combination of choosing 3 out of 7 boys. So let's calculate both of these. So this is 8 factorial over 8 minus 2. Actually, we'll just start simplifying these in advance. 6 factorial, 2 factorial, multiplied by 7 factorial over 7 minus 3 is 4, and 3 factorial. And because this is multiplying 2 fractions, I don't need a common denominator or anything. I can actually just combine those all as one fraction if I want to. So if for some reason simplifying something from over here and over here worked out real nice, I am allowed to do that. So let's see, I'm thinking I'll cancel 8 partially out with a 6, so I'm going to write that as 8 times 7 times 6 factorial. And I think I can cancel the 7 out with this 4 nicely, so I'm going to write times 7 times 6 times 5 times 4 factorial. And let's see, 6 factorial is going to get canceled out in a second. 2 factorial is the same as just multiplying by 2. 4 factorial is going to get canceled out. And 3 factorial is the same as 3 times 2. So let's cancel out and simplify. And it looks like, well, 3 times 2 is 6. And this 2 and this 8 could reduce to 4. So my simplified math is going to be 4 times 7 times 7 times 5. Which, what's that going to be? 4 times 5 is 20. 7 times 7 is 49. So that's 49 times 2 is 98. I believe that's 980. Let me just verify. 4 times 7 times 7 times 5. And yeah, 980 is correct. So we can see that we can represent kind of compounded problems with 2 situations, as long as they're independent of each other, of course, calculating each of those separately and just multiplying them. And we can answer kind of a more complicated question and figure things out like that. Alright, so hopefully that explains some of the more intricate problems in trying to determine whether it is a permutation, combination, or kind of compound situation. And I look forward to seeing you guys in the next video. Thanks.